Welcome to Study Loop.
For this situation, we know that the focal length f is equal to negative 30 centimeters, and the distance to the image I is equal to negative 15 centimeters. And for part A, it wants to know if the mirror is concave or convex. But since f is negative, we know that this is a convex mirror. So right away, we can say convex since f is negative. We can box in convex as our solution for part A. Part B says, okay, well, since we know part A, what is that focal length? But we were given that in the question. So f is just equal to negative 30 centimeters. And we can simply box in 30 centimeters, or negative 30 centimeters as our solution for B. Part C says, what's the radius of curvature of this mirror? By definition, radius of curvature r is equal to 2 times the focal length f. So this is equal to negative 60 centimeters. Part D wants to know what the distance from the mirror to the object is. So to do that, we're going to use the equation that says 1 over the distance to the object, p, plus 1 over the distance to the image, I, is equal to 1 over the focal length, f. Or in other words, we can rearrange this to solve for p. P is equal to I times f over I minus f. So plugging in the values for I and f into this expression, we find that p is equal to 30 centimeters. And that's positive, and we can box it in as our solution for D. Part E wants to know the distance to the image, but that was given. So part D, distance to the image I, is equal to negative 15 centimeters. Part F wants us to calculate the magnification of this image. So by definition, magnification M is equal to minus I over P. Plugging in those values, we find that magnification is equal to 0.5, or 1/2. Part G wants to know if the image that is formed is real or virtual. All we have to do is look at the sign for the value of the image I, and it's negative. So we can say since I is negative, the image is virtual. And we can box in virtual as our solution for G. Part H wants to know if the image that is formed is upright or inverted, and we just have to look at the sign of the value for the magnification. And since M is positive, the image is upright, or non-inverted, but we'll just say upright. It's the same thing. We can box in our solution for H. And then finally, part I, it says, is the image that's formed on the same side or opposite side of the mirror as the object that formed it? And since the image is virtual, it is on the same side, or excuse me, it is on the opposite side. So a virtual image for a mirror is on the opposite side, and a virtual image for a lens is on the same side. But this is a mirror, so this is on the opposite.